Hi, hello everyone. This lesson is about upper and lower bounds. Upper and lower bounds. What's meant by upper and lower bounds? Let's read the definition. When a measurement is rounded to a given degree of accuracy, its actual value, he asked about the actual value. Its actual value lies within a range. The lower bound is the smallest possible value it could have been, and the upper bound is the largest. The upper bound is the largest. Here is written as the smallest. No, upper bound is the largest value it could. Okay, we talk about upper and lower bounds. Lower bound is the smallest. Again, when a measurement is rounded, it's already rounded to a given degree of accuracy. Its actual value lies within range of lower bound. Lower bound is the smallest possible value it could have been, and the upper bound is the largest value it could have been. Here he wrote smallest value it couldn't have been. To find the bounds, take the degree of the accuracy, halve it. No, there's the steps how to get the upper and lower bounds. First, know the degree of the accuracy, then halve it, and then add and subtract it from the rounded measurements. Example, a length is measured as 10 centimeter to the nearest centimeter. This value is rounded. This already rounded to nearest centimeter. Nearest centimeter, just 1 centimeter, okay? This is called the degree of the accuracy. Halve it. Halve means divide by 2. 1 divided by 2 equals 0.5. Add and subtract from the amount. Subtract 0.5 from 10, it will be 9.5. This is called lower bound. If I add 0.5 to 10, it will be 10.5. This is called upper bound. I prefer to write it as inequality, like this one. X means all the numbers which rounded to nearest 1 centimeter equals 10. Greater than or equal lower bounds and smaller than or equal upper bounds. That means x greater than or equal 9.5 and smaller than 10.5. Notice that there is equal sign here, okay, to the lower bound, and here there is no equal sign. In the side of the upper, we don't write equal. To the lower, we write equal, greater or equal, and the smaller, like this. Another example. Eva measures the diameter of a circle as 15.9 centimeters. She uses a calculator to work out the area. She says the area is like this one. Round this answer to an appropriate degree of accuracy. If you want to round this, you can round it to the nearest whole number, which equals 199 whole number without any decimals. Here, 5 will increase 8 by 1. It will be 199. If you want to round to the nearest whole number, it will be 199, like this one. Without any decimal, this in the 10th place, 5 or more, increase the units place by 1. It will be 199. If you want to round to 1 decimal place, look at the right, it will be 5. 5 increase 5 by 1, it will be 6. And so on. If you want to round to 2 decimal places, it will be 198.5. And on the right of 5, 6. 6 increase 5 by 1, it will be 6, like this one. What about the lower and the upper bounds? Let's take an example for lower and the upper bound like this one. A number x rounded to the nearest 100 is 1500 or 1500. Complete the inequality to show the possible value of x. So we ask here about here he asks about the lower and the upper bound, lower bound and the upper bounds. First, look at the degree of the accuracy to the nearest 100. Nearest 100, nearest 100 here is called the degree of the accuracy. First, know the degree of the accuracy. Then, halve it. Half divided by 2. If we divide 100 by 2, it will be 50. Okay? To get the lower bound, subtract 50 from this value. 1,500 minus 50, it will be 1,450. This is called lower bound. And if you want to get the upper bound, add 50 to 1,500, it will be 1,550 like this. The time taken to run a race is 9.87 seconds, correct to 3 significant figures. Write down the upper limit for the time. To get the upper limit, put 0 here. Okay? Put 0 here. And add 5 and then subtract 5. Add 5 to get the upper bound and subtract 5 to get the lower bound. It will be 9.875. This is called upper bound for the 3 significant figures. Distance between two cities is 17,000 kilometers, correct to the nearest 1,000. 1,000 here, degree of the accuracy. Halve it, it will be 500. If we halved 1,000, it will be 500. Complete the inequality complete the inequality to show the limits of the distance. Limits of the distance between here. He subtract 500 from 17,000 to get the lower bound, which equals 16,500. He wants you to get the upper bound. Upper bound, add half the degree of the accuracy to the amount. It will be 17,500. Like this one. The mass of a bag is 1.00 kilogram, correct to 2 decimal places. 2 decimal places means 0.01, 2 decimal places. This is called degree of the accuracy. Halve it. 0.01 divided by 2. It will be 0.005, like this one. To get the upper bound, add this amount to the original or to the rounded number. Add 1 plus this amount, it will be like this. This upper bound. He asked about the lower bound. So subtract this amount from the rounded number, it will be 1.00 minus 0.005, which equals 0.995, like this one. Okay, this is called lower bound and this is called upper bound. First, you have to know the degree of the accuracy, then halve it, then to get the lower bound, subtract the rounded number or subtract the half of the degree of the accuracy from the rounded number. If you want to get the upper bound, add this amount to the rounded number. Length of a book is 25 centimeters to the nearest centimeters. So 1 centimeter, halve it, degree of the accuracy 1 centimeter. Halve it, it will be 0.5. Complete these statements about the length of the book in lower bound. Subtract 0.5 from 25, it will be 24.5. The upper bound, add 25 to 0.5, it will be 25.5. Okay? And some books write this amount 25 25.4 recurring 4. So I prefer to write the upper and lower bounds as an equality. X greater than or equal 24.5 and smaller than or equal to smaller than without equal 25.5, like this. Okay, or you may write 25.4 recurring 444 repeating decimal and an infinite repeating decimal, which is called recurring. Eva thinks of a number when she rounds the number correct to two significant figures. The answer, like this, 43,000. When she rounds the number correct to three significant figures, the answer, 43,500. Complete the inequality to show the limits for Eva's number. Eva thinks of a number when she rounds the number correct to two significant figures. The answer, 43,000. When she rounds the number correct to three significant figures, the answer is 43,500. Complete the inequality to show the limits of Eva's number. Okay? The numbers which includes this number, when you round to significant, two significant, or three significant figures to get these numbers, it will be 43,450 and 43,500. Okay? Notice that here there is equal sign, but here not reach for this number because there is no equal sign here. Not reach to 43,500 before it. Because if you round this number to two significant figures, it will be 44,000. 44,000, not 43,000. So take the numbers before 43,500 and the number may be 43,450 because here we have an equal sign. If you round this number to two significant, it will be 43,000. If you round this number to three significant, 5 increase 4 by 1, it will be 43,500. Okay, 43,500. But if you round this number to three significant, okay, it works. It works, 43,500, but two significant, it will be 44,000. It doesn't work. So don't take this number. We don't reach for this number. Take the numbers before it and take this number and the number above it or greater than it. Tell this number. The numbers included between two numbers, this the limits for Eva's number. Number of people in a stadium, 24,300, correct to the nearest hundred. Nearest 100, the degree of the accuracy is 100, so of it will be 50. Subtract and add. To get the lower bound, subtract 50 from this number. To get the upper bound, add 50 to this number. Find the smallest possible number of people. He asks about the lower limit, so subtract this number from this number. 300 minus 50, it will be 250, 24,250. This number is called lower bound. Lower bound. To get the upper bound, it will be 24,350. Another one. Test. Let's take the test. 15 multiply 10 power 2. It will be 15 multiply 10 power 2 means 100. It will be 1,500. 3.25 multiply 10 power 4. 10 power 4 means 10,000. Move the decimal point to the right 4 places and put 2 zeros instead of the digits which doesn't exist or don't exist. Digits don't exist. 19 multiply 10 power 0. 10 power 0 equals 1, so the result will be 19. 6 multiply 10 power negative 1. 10 power negative 1 means 1 over 10, or if you see negative power above the 10, change the operation sign, make it the opposite operation. Instead of multiplication, make it division. And change the power above the 10. It will be 6 divided by 10. Instead of saying 6 multiplied by 10 to power negative 1, say 6 divided by 10 power 1. 6 divided by 10 equals 0.6. The same. 45 multiply 10 power negative 3. The same as 45 divided by 10 power 3. If you change this sign, change the sign of the power. 45 divided by 10 power 3, 45 divided by 1000 will be 0.045. 270 divided by 1000, which equals 10 power 3, it will be 0.27. Put decimal point after 3 digits from the right. Divide by 10 power 0 means divided by 1. It doesn't affect. 0.45 divided by 100, 10 power 2, 100. Divide 100, move the decimal point to the left 2 places. It will be 0.0045, like this. Circle 0.45, divide 10 power negative 1, it will be times 10 power 1. Times 10, it will be 4.5, like this one. Move the decimal point to the right. This 0.45 times 10 power 1 divided by 10 power negative 1 means times 10 power 1. Divided by 10 power negative 2 means times 10 power 2, which equals 100. It will be, move the decimal point to the right 2 places, it will be 8.5. 6 divided by 10 power negative 4 means 6 times 10 power 4. 10 power 4, 10,000, it will be 60. 8 multiply 0.3, make the multiplication operation without the decimal. It will be 8 multiply 3, 24. 24. Then put the decimal after 1 digit from the right. It will be 2.4. Negative multiply positive equal negative. 5 multiply 9 equals 45. Put the decimal after 1 digit from the right. Here, 16 multiplied by 2, which equals 32. Put the decimal point after 2 digits from the right. It will be 0.32. 0.12 multiply negative 40. Positive multiply negative equals negative. 12 multiply 40, put 0, the 0 for 40, put 0. 4 multiply 12 equals 48. Put the decimal point after 2 digits, it will be negative 4.8. 0.03 multiply 0.2. Ignore the decimal, it will be 3 multiply 2 equals 6. Put the decimal point after 3 digits from the right. Why? Here, after 1 digit, here after 2 digits, it will be after 3 digits, like this. Ignore the decimal on the multiplication. First, we ignore the decimal. 7 multiply 5 equals 35. Put the decimal point here after 3 digits, here after 1 digit, it will be after 4 digits, like this. This operation differs on the division. To make the division, first you have to make the divisor whole number, not decimal. You can't divide with a decimal divisor. To make 0.2 whole, multiply by 10 here, multiply by 10 here. It will be 60 divided by 2, which equals 30. Multiply by 10, multiply by 10, it will be negative 550 divided by 5. Make the divisor whole number, not decimal number. Negative divided by positive equals negative. It will be 110. 5 divide 5, 1. 5 divide 5, 1. 0 divide 5, 0. Multiply 100, multiply 100. It will be 400 divided by 5, which equals 80. 32 divided by negative 0.08. Multiply 100, it will be negative 8. Multiply 100, it will be 3,200 divided by negative 8. Positive, negative, it will be negative. 32 divide 8, 4, and put 2 zeros, like this. Multiply 100, 36 divided by 9, it will be 4. Multiply 1000 to make it 2 without any decimal. Multiply 1000, it will be 3200. Start from the left. 32 divided by 2 equals 16. Put 2 zeros, like this. Work out this. Work out the answer to this fraction. 24 multiply 0.5, ignore the decimal. 5 multiply 24 equals 120. Put the decimal, it will be 12 over 3 multiply 2, 6. Put the decimal after 2 digits. like this. Then divide. To divide, you have to make the divisor whole without any decimal. Multiply 100 on the numerator and the denominator. Multiply 100, it will be 120. Then multiply 100, it will be 6. 120 divided by 6 equals just 20. Compound percentage. Work out the final value after these compound percentage changes. 160 increased by 20. 160, the original amount, which expresses 100%. 100% will increase by 20. It will be 120%. Its multiplier equals 1.2. 120%, the same as 1.2. Cancel, or 120 over 100, it will be 1.2. Then increase by 10%, it will be 110%, that means 1.1. Use your calculator to get this answer. Like 160. Stay with me. Okay. Where is my calculator? Here, 160 times 1.2 times 1.1. 211.2. 60 decreased 100% minus. Minus what? Minus 25%, it will be 75%. Its multiplier 0.75. Then decreased another time 40%, it will be 60%. That means 0.6. Multiply 60 times 0.75 multiply 0.6, it will be 27. Like this, 27. Circle the correct multiplier. Increase 10, increase by 10, then increase by 10, 110%, which equals 1.1. 1.1. Increase 100% plus, decrease 100% minus. Multiply 1.1 times 0.8. 1.1 times 0.8, it will be 0.88, like this one. Decrease 25%, decrease 100% minus 25%, it will be 75%, 0.75. Then increase 40, increase 100% plus 40, 140, that means 1.4. Multiply 0.75 by 1.4, multiply by 1.4, 1.05, this one. Population of a village is 800 people. Population is predicted to increase at steady rate of 5% per year. After 1 year, it will be 800 times 1.05. After 2 years, 800 multiply 1.05 for the first year and 1.05 to the second year. 800 multiply 1.05 for the first year, 1.05 for the second, 1.05 for the third year, and get your answers. Okay? What does the calculation 800 multiply 1.05 to power 4 represents? 1.05 to power 4 means 1.05 times 1.05 times 1.05 times 1.05. That means the population after 4 years. Okay? Increasing of population after 4 years. This after 10 years. After how many years does the population of the town first go above 1,500 people? You should calculate. Calculate 800, multiply 1.05, multiply 1.05 power 2, 1.05 power 3, power 4, power 10, power 5, and so on, to get number above 1,500. Okay? After n years, it will be like this: 800 times the same as this one, But instead of 10 or 5 or 4, put n for n years. Make the bar equals n.